Welcome back to Balvikan Bharti with Abhilash Sarkar. In the last video, what we learned last is Bernoulli's theorem. There, we said in a case of steady state flow for an ideal fluid means that is incompressible, irrotational. This kind of fluid, when it is flowing as in a steady state flow, that the energy at any 2 point is same. The total energy at 1.1 and total energy at point 2 is same. That means energy at any point of time is conserved, and that energy is given by the pressure energy plus potential energy plus kinetic energy per unit volume divided by volume is equal to constant. So this was my formula. So after that, what we did, the second phase of this is the first formula. The second formula, what we did, we have divided it into divided by rho and g. That means specific gravity. Specific gravity of any fluid we have divided, and there we find that is converted into pressure head plus potential head plus velocity head. So that also constant. So if I say what are the equation, energy equation, you know, for any energy equation that is measured in terms of joule and all that, joule. So if I divide with the volume, we'll get the respective equation, joule per volume, and that. So pressure energy actually that is meant by the energy is equivalent to the potential energy, whereas for that arrangement where we are doing we are having flow through this kind of thing. So this, the center of mass, height from a reference, this is count as a potential energy, but due to which the flow is established, the prior to that energy, this could be a prime mover, this could be a prime mover who are pumping this and causing a pressure difference P1 and P2, where P1 is more than P2, so that's why its flow direction is this way, or some static head. That means some reservoir is there, from there flow is taken into this. Okay, flow is taken into this. Okay, and it is flowing, and there is some head from this to this, there is some head. This is causing pressure head. So this is meant by pressure head prior to the flow, and the potential energy is caused due to some reference from which that the flow path is established, and their respective head, that potential head at 2 point with that reference. Understood? This is the pressure energy caused to flow, and during flow some reference frame if I choose, with that respect, if I take any point 1 and 2, that point the potential energy and velocity energy, we understand as the flow is as the fluid is flowing, there must be some velocity across the path. So at P1 at point 1 there could be one velocity, and V2 and point 2 there will be another velocity. So that is causing the kinetic energy. So you can understand from the common point of view, this cumulative is constant. So that means any energy down, other energy will make up to find that sum is same. So that means here if we can say that pressure energy for any instant of time is same for this arrangement. If this arrangement is constant, or the pumping, there is a constant work done by the pump is doing on, so that energy being constant, So that energy concentrated during the flow is potential energy and kinetic energy. Now in this case, potential energy is measured by the height rho and g, here height rho and g. So now you can see the height is here is less, here is more. So that means that potential energy here is much. So the kinetic energy will be less, and due to that velocity will reduce. So this is the or otherwise if it is downward somewhere, so there velocity will potential energy is less, so velocity will increase. So that is the concept behind that. Okay, so the now pressure head, it is even if it is given in the form of meter or means length unit, but this is actually meter upon volume into rho into g. So this part is what? This part is your weight, isn't it? Volume into rho is mass, mass into g is your weight. So that is the head in length per weight. Per weight means segment wise, if I say in a particular segment that mass is this much, so this has having some weight. So this weight, mass is there. So we are talking about the energy conservation. The energy conservation at this point, if I add with the respective weight of this, so I will get the energy conservation here also. Okay, so now this is incompressible, the volume will not change. Okay, rho is not changing and g is constant for any particular region. So this is constant. So weight flow rate also for a particular steady flow is constant. So no flow parameters will going to change in steady state or ideal flow. Okay. So now we will do some sum on this. So let me bring the first sum for you. First sum on this: a non-viscous liquid is flowing through a frictionless duct of cross section varying as shown in figure, which of the following graph represents the variation of pressure P along the axis of the tube. So now I will draw the figure that is given. It is something like that. So this is This is a circular, but is a reduced diameter, and this is center where that, and this is exaggeration on which the flow is happening, and the graph is given as uh, 4 graph is given out of this. This is P versus X is drawn. First graph is given is like this. 7 graph, same P versus X, the reverse of that. Third one is given as straight line, and the fourth one is given as the line dotted and firm line this way. So which one is correct? Okay, so as you know, for any this is given the frictionless, that means it's a ideal fluid they are talking. Friction is not coming along the duct, so there is no strain is developing, so that means there is no loss due to the velocity is same, and this is a complete steady state flow. We can assume a non-viscous, that means this is a part of the a part of a fluid which is comes under ideal fluid. For ideal fluid, non-viscous means there is no frictional losses, and liquid is flowing through a frictionless duct, and duct also frictionless, that means there is no strain due to the duct, and cross section is varying as one. Okay, so if I say this is 0.1 and this is 0.2 at this point, so what we can assume, this is velocity 1 here, pressure energy P1, okay, here velocity is V2, pressure energy P2. So as per Bernoulli's theorem, so what we can see, if I take any reference, so from there the center of mass having other equal distance, okay, so that means the height part can be nullified. What is the pressure energy plus your half rho V1 square, this is the kinetic energy, plus potential energy is equal to rho G H1 and equal to P2 at this point plus half rho V2 square plus rho H2. Now H1 is equal to H2. Okay, so now height here is H1, this is H2. As it is horizontal, these are equal, so this part is cancelled. So what is remaining? P1. So I am bringing P1 minus P to one side, and what I get, half rho V2 square minus V1 square. Okay, this I will bring, and another part that we can this is cross section is, so cross section is reducing and it is steady flow, so we can also apply what, so this top part is not required, I can rub it out, ultimate equation this one, and we can use the continuity equation. Let's say this is cross section A1 at this place, A1 V1 is equal to A2 V2. This also can be applied. Now V is velocity, so if I can change this part with let's say any of these two, V2 in place of V1 if I put, okay, so V2 is equal to A1 by A2 into V1, that I can replace, so I'm replacing half into rho into V2 is this one, so V1 sorry, in place of V2 I'll put this one, so this will again V1 square will come and along with this, so V1 square I can take it out, and this will remain as A1 square by A2 square minus 1. Now A1 is this, A2 is this, so A1 by A2 is more than A2, so A1 by A2 is greater than 1, isn't it? So what I can write, minus 1 is greater than 0, so this part is your positive part, so this is obviously a positive, so delta P, that pressure difference between this and this point, is a positive value, and that depends on half into this part. A1 is constant, so this point along with the row I can put all as a constant. Then this is depends on v1 square, so delta p. Now v1 square is a now this equation particularly, if I rub all this, and only I will get what a delta p is depends on k into v square. So this is the pressure difference from here. So pressure difference anyhow you can understand this is positive. So that means P1 pressure is more than P2 pressure. Delta P was what? P1 minus P2 is equal to delta P, and that is equal to P1. This is a positive quantity. So that means P1 is more than P2 and it is reducing. So that means any case out of this reduction is this is increasing. So this cannot be, and this is flat. This cannot be, and this is also reducing. So out of this and this is possible. Now this is what you can see, a linear P against X, a linear means it's a straight line. So we cannot assume any variable. This is variable, this is also variable. So we cannot assume any variable of order 2. If it is linear, it has to be 1. So this is also not possible. So the perfect one is this one. This is also resembling something. If P is in y axis, so y is equal to 4a into x square. If you learned this in your academic, this is an equation of not like that, sorry, effect. This can be represented in this way. How? That v1 square is equal to 1 by k into delta p. Now delta p is the pressure difference this way, p minus p, or delta p you can assume that the difference, this is the slope, this is the delta p. If I assume this also, this is delta p, and delta p v square is equal to this way. So v square means any velocity at any point with respect to that, this is equal to depend on delta, means the delta p, if I say is a dependent variable v1 square, so that any change of v1 velocity, this means the x-axis, this value is, if we go on changing, means if I go this way, that delta p is the value, it is changing, means from p1 value, let's say this was p1 earlier, now at x, now x changing, for changing x only, that v is changing how much, for v is the velocity this way. How it is related to x? Because v is nothing but x by t. Okay, now v is x by t, that means if any particular time if I considering, so t also can be considered constant. So for v is velocity is distance upon time. So if this is constant, so v is proportional to x. So now this can also be converted into some constant, that t is a constant, 1 by t whole square, this is constant, into x square is equal to 1 by k. So now this further is added to this is t square into delta p. So now it is good. Now if I change x a bit, so then delta will change in second order of x, and as delta p is equal to p1 minus p2, so that means this is increasing, so that means increasing in order 2. This p1 minus p2 delta p, this is positive, that means p1 is higher than t. So whatever p1 is here, if I go to any point, let's say from 1 point to 2 point, is due to the change in x, p is reducing because p1 minus p2 is positive, so that means p1 is always higher than p2. So understand, this is a graph that only will satisfy this situation. Understand? Okay, so we'll move on to the second problem. Problem number 2. Water is in streamline flow. Water is in streamline flows along a horizontal pipe with non-uniform cross section at a point in the pipe where area of cross section is 10 centimeters square. The velocity of water is 1 meter per second square and pressure is 2000 Pascal. The pressure at another point where the cross section area is 5 centimeters square is how much? Okay, so now read it out again. Water is flowing a streamlined flow along a horizontal pipe. So horizontal pipe may be pipe of non-uniform cross section. So as it is given, this is of kind this much non-uniform cross section. Okay, but that is it is non-uniform cross section, but the shape is uniform. That means the reduction in the cross section is uniform. So that means we can assume the center of line is passing through just the center of line of the body, the flow center line, or you can say the center of mass is flowing through the center line of the body. Okay, so that means when we will take some reference, so at point 1 and point 2, if I want to compare, their height at this point are same with that same reference frame. The same reference frame, the height of the point from that reference frame, this is your reference frame, so that height is same at a point in the pipe where the area of cross section is 10. So this is, let's say, 10 centimeters square. The velocity of water is here is 1 meter per second square. 1 meter per second, not second square. 1 meter per second, and the pressure is pressure energy is 2000 Pascal. Okay, the Pascal is Newton per meter square. The pressure at another point where the cross section is 5, where the cross section is given 5 centimeters square. Okay, so how is the velocity. So the first thing for any ideal fluid being flowing in steady state flow, the first equation is equation of continuity. A1 v1 is equal to a2 v2. Why I am doing that? Because velocity is given here, velocity is not given here. So what you need, why the cross section of right section, the pressure you will need. So to get the pressure from the equation of conservation of energy, we need the velocity. Velocity can be achieved from this. Okay, the cross section is given as 10 here, and v1 is 1 into 1, a2 is 5 here, and v you can get. Okay, so v2 is how much? Is 2 meter per second. So this is my finding. Okay, this part is over. Now as it is horizontal, the potential energy in these 2 points are same. So only thing remaining is your v, you remember, is 2 meter per second. Okay, p2 plus half rho v1 square is p1 and p2 plus half rho v2 square. Fine. P1 is 2000. Here I am not changing, it is Pascal, because Pascal is the unit of pressure energy. Okay, here itself. So and this, now we need to have the energy must same. So half, when energy is from m v square by what we are dividing v. Now this is equal to what? Half you don't remember, the m is equal to mass, velocity is L square t to the power minus 2, and volume is L Q. So L cancelled out, m into L by t square. Okay, so m into, if I say L multiplied the ml, so L square will come. So ml into t square is equal to what? That is equivalent to Newton. Mass into length by t square, that means m into a, that is the force unit, the Newton per L square. Now you can see this unit is equivalent to this equivalent, because this is Pascal, this also equivalent to Pascal. So you need not to worry about the unit. So this unit is being taken care. So if I put 2000 only, I need not to worry, because this will match. So all the units will come in the same unit, Pascal. So P2 whatever I value I'll get Pascal. So need not to worry about the unit. So rho of water, as it is in centimeter square. So I will keep this. The density of water is 10 to the power 3, but Pascal is Newton per meter square. This is I kept in centimeter square. I got V in meter per second square. So as B is in SI units, so rho has to be in SI unit, 10 to the power 3 for water, into V1 is equal to 1, that is equal to P2 I need to find, plus half into rho is also same here, and this case is equal to 2. Okay, so what is P2 then? P2 is equal to 2000 will be there, plus half 10 to the power 3 will be there, and this will go this side, so this will be a minus, because 1 minus 2. So ultimately 2000 10 to the power cube half, that means it is equal to 500. So all total 10 cube means 500, and this 2000 minus 500 is equal to 500. So the potential in the pressure energy here, the value I will get 2000 minus 500, sorry, this is 1500, sorry, 1500. So I will get 1500 Pascal here. Fine. So now you can see, we will compare, as velocity energy is pressure energy high, the all total is the pressure energy plus velocity energy, velocity is less. As the velocity is increasing, so pressure energy, because potential energy is same, so definitely the pressure energy will reduce. So that also clarify your doubt, because energy is conserved from there. We got that P2, so it is confirming the state of flow is air. All the energy, as because velocity is less, then pressure energy has to reduce air. So this is equal to this much of Pascal. So this is the need the pressure at another point where the cross section is fine. Understood? Okay, fine. I will move on to the next problem in the next video. There may be 4 or 5 another problem on the basis of this, because there's a variety of problem is there. So I will show all this, then after I will move on the another theory. So thank you for now.